Either geometry. This is Mr. Lamb with the Unit 5 test key. I'm going to jump right into page number 1. Know that page number 1 is out of 14 total points. Page number 1 is out of 14 total points. Okay, so question number 1 is worth 2 points. All right, so it's worth a 2-pointer. And it wants us to find x and y. Obviously, you get 1 point for x and 1 point for y. So one of the things that I know is if this thing is in fact a parallelogram, that the opposite angles are congruent to one another. So that means 60 has to equal 5y. So divide 60 by 5, and you get y to be 12. And if I plug 12 in, 5 times 12, that means this angle up here is obviously 60 as well. Now, consecutive interior angles, so if I take this 3x plus 60, it does not equal 60. It has to be supplementary with 60. So that means if I take the 60 right here, and I take this one, 3x plus 60, and I add them together, it has to equal 180. That's what it means to be supplementary. Okay, so that's combined like terms, 3x, 60 and 60 is 120, equals 180. So that means 3x has to equal 60. I'm subtracting 120 on both sides and then divide both sides by 3. 60 divided by 3 is 20. So question number 1 should be 20 and 12. Question number 2, this is also worth 2 points. And if this thing is going to be a parallelogram, one thing you need to know about parallelograms is that their diagonals bisect each other. The diagonals bisect each other. So I'll do my left to right diagonal. Those two pieces have to be the same. So as I take a look at this, 9r minus 17 has to equal 3r plus 13. They have to be the same. Subtract 3r on both sides. Add 17 to both sides. So 3r equals 30. Divide by 6. And r is equal to 5. Similarly, the other diagonal. This piece has to be the same as the lower piece. So if I take my 4s minus 3, and I set it equal to the lower right-hand piece, 7s minus 24. Subtract 4s on both sides, gives me 3s. Add 24 on both sides, gives me 21. And then I divide by 3, and I find s to be 7. So, question number 2, you had to know that diagonals bisect each other. All right, as I jump down here to questions 4 and 5, there are 3 points per question. So question number 3 is going to be worth a grand total of 3. And question number 4 will be worth a grand total of 3. And the first thing that I have to look for in question number 3 is, what type of quadrilateral is this? It is a special type of quadrilateral where all of the sides are the same. We call this a rhombus. It is a rhombus. That is the first point. Second point is for x. Third point is for y. So looking up here, I have 4x plus 17 and 8x minus 3. The relationship between those two numbers, because it's a rhombus, they are the same. So 4x plus 17 has to equal 8x minus 3. Subtract 4x on both sides. That gives me 4x on the right. Add 3 to both sides. Gives me a 20. Divide both sides by 4. 20 divided by 4 is 5 for x. And for y, consecutive interior angles. are not congruent. They are supplementary. They are supplementary. So I'm going to jump in here and say that 7y minus 5 plus the 108 has to equal 180. So that is 7y, negative 5 and 108 is 103. Subtract 103 on both sides. And that is going to give me 77. Divide both sides by 7. And y is equal to 11. All right. Number 4. Same thing, 3 points. I'm looking for the type, and then the x and the y. I see that all 4 corners are 90s, which tells me that it is a rectangle, and all 4 sides are the same, so it is a square. It is a square. I'm going to find y first. 5y plus 16 and 10y minus 29. Those two things are opposite sides. They have to be congruent. So 5y plus 16 equals 10y minus 29. Subtract 5y on both sides. So 10y minus 5y is 5y. Add 29 to both sides. So 16 plus 29 is 45. 49 is 45. Divide by 5. And 45 divided by 5, y is 9. Now to find x. I was very specific that x was not the whole angle. X was just a piece of the angle. The other thing you have to know about squares, the diagonals bisect each other. The diagonals are congruent. And also in a square, the diagonals are angle bisectors. So it cuts that 90 degrees in half. So that little half angle is half of 90. So that means 6x plus 21 is half of that 90 degrees. So 6x plus 21 is equal to 45. Subtract 21 on both sides. It's 24. Divide by 6. 24 divided by 6 is 4. And number 5, the last one down here. There are 4 parts. Obviously, it's worth 4 points. Point for every line. And it says the diagonals of a rectangle. So I know that this is a rectangle, so that means all angles have to be 90, 90, 90, and 90. And just some of the things I know. If I have a 56-degree angle shown, if x, y, w is 56, the other one has to be 90 minus 56, because that whole angle has to be 90. So that is 34. And it's a rectangle, so the top and bottom are parallel, so 34 has an alternate interior angle up here. It's 34. 56 then will be here. The other one. Oh, and then I know that WY, the whole diagonal is 94. So from W to Y is 94. I'll take half of that because the diagonals bisect each other. So 94 divided by 2 is going to be 47. So this piece here is 47, 47, 47, 47. Reason why they're all 47, remember in a rectangle, diagonals are congruent and they bisect each other. So both of them have to be 94, so half of 94 is 47. Okay, now let me circle 47 because that is the length of a side, not an angle. I want you to know that those are sides, not angles. 56 is a degree, 34 is a degree. So now if I look at the triangle at the top of this, so if you're kind of looking at this like it's an envelope here, this triangle up top, let me highlight it. That yellow triangle up top is an isosceles triangle. It has two angles that are two sides that are both 47. That means base angles have to be congruent. So if one is 34 degrees, the other one has to be 34 degrees. Same thing at the bottom. Right, this bottom triangle, let's see if I can't flip up and down. This triangle down here at the bottom is an isosceles, 47, 47, so base angles have to be congruent, 34. And again, now I know if that's 34, this piece here is 56. All right, so this one up here is 56. Whew, so a whole bunch of information. Now the angle's in the middle, right? As I take a look at these triangles, highlight this again, highlight this one. Right, this triangle has to add up to 180 degrees. So since I know two of them are both 56, I can do 180 minus 56 minus 56 means this angle has to be 68. And the vertical angle also has to be 68. And I can do the same thing at the bottom. All right, if I look at the bottom, I have a triangle, 180 minus 34 is 112. And up here is 112. So really, I have made everything, every little part of this thing has now been identified. So now let's just look and see what is it that they want us to know. So from Z, Y, W. So Z, Y, W. That angle right down there, 34 degrees. That. Next one is XWO. XWO. That angle is also 34 degrees. Okay, next one is ZOY. ZOY. Inside, that is 112 degrees. And the segment from X to O is 47 units long. So that is a whole bunch of information in question number 5. But understand that because rectangles have that great property of 90 degrees in the corners, diagonals are congruent and they bisect each other, really gives me a really good chance to get that problem done. If this would have said that it was a square, understand that those diagonals would have cut the corners into 45 and 45. But if they're not 45s, that's one of the ways that I can tell that something is not a square at all. So that is the end of page 1. Again, that was worth 14 points.